Hello everyone. My name is Umair Durrani, and today we are going to revisit our second app project, which was to make an app that shows the different talks from PositCon 2024. All the talks are available on YouTube, and on this project, I used Shiny for R to and actually it was not only me but also other members, and together we worked on this app that shows you the talks, and you can explore the talks and you can watch the talks. This is another version of that I tried to create using a multi-page app framework. So this is fast HTML. That's a package in Python. And using fast HTML, I was able to create a multi-page app. So on the home page, you have the search bar here. You can search it by, you can search any of the talks. For example, if I type the speaker name, or if I type anything in the description or in the title, then the talks are filtered. And if you click on the replay session button for that talk, we see this. So with fast HTML, you have to work more, I believe, to create a nice UI. So for this first page, the UI was changed because I used some custom CSS. But for the second page, the page for the talk, we see that it's just the default HTML. There's no CSS applied to it, which is something that Shiny does take care for you. If I use the default Pico CSS for fast HTML, I think it takes care of that page as well. But with Pico CSS, the UI is very simple, and so I wanted to explore using custom CSS. So this is pretty fast compared to the Shiny version of this app that was our project too. And that's because we created multiple pages, and there were 106 talks. So that created 106 different tabs for the Shiny version of the app. And that was obviously making everything slow when the app was first launched and loading. But because this is multi-page, it uses different routes for, and each route is relevant to different pages. And the home page has the route uh, as its main route. And so in that case, it works pretty fast. And we can see that here on my screen with main.py file, we have the root, which is the home page. And similarly, there is a route for filtering the talks and so on. So since we mostly discuss about Shiny, I'm gonna switch to our main project for this period, which is to create uh, an app that takes in the input of road names. So here is the road names repository on the Shiny Meetings organization. And the main idea is that we want to find similar roads when we enter just a single name of the road. For example, Prince Street or Ontario Street, any street name that you enter, it should find all the roads with similar names in the uh, in US and Canada. So I have data from the GeoFabric website that gives the data in the PBF format. When I read those individual files for each region of US and Canada, it automatically created GPKG files. And when I was reading those files, I specified that I want to use the line strings because I'm interested only on roads. So it created those GPKG files only for line strings automatically. And then I read them in and I converted them into Parquet files. And now using the GeoArrow and the Arrow packages, I am able to query the Parquet files by asking it to find all the roads that have this particular road name. So in this example, I use this Muldoon Road as the input. And here, if I run geo arrow, and then the main thing I'm doing here is taking the open dataset function from arrow, providing it all the URLs, all the sources of the Parquet files. And then when it is opened, we are looking into the detecting the the road names, which match this Muldoon Road in this example. So there is this column name in all of these files. And then in this example, I'm just simply looking at a sample of 50 roads and then finally convert them into SF. Now, each of these files are huge in size. If I go to my main directory and then go to the data folder, so here you can see that the Parquet files are in hundreds of megabytes of size. And this is after I have removed all the columns and only kept the geometry column of the line strings and the name column, and I believe the OSM ID column. So after removing all of that, I still have these huge files. So the challenge here is to be able to somehow use these Parquet files in a deployed app. So either I need to put them somewhere remote, like on a storage, in a cloud storage, and then try to provide the URL here, or I can maybe also try the GitHub repository, but I think the limit for individual files there is 100 megabyte. So that could be one problem. Another thing that I am trying is to use DuckDB, where I created a database using all of these files. And I tried that, and still created a DuckDB database of 2 gigabytes, which is not as big as 200 gigabytes. That was the original size of all the files. But still, the challenge is, where do I put this? I don't want to bundle this with the app. So those are the challenges. But this works pretty good locally. If I want to run this, and I can actually also time it. So because we are looking at 6 different Parquet files, and then using 50 as randomly sampled files, it takes a few seconds. If I remove this thing and use only the first 50, then it is much quicker. So filtering this part is not that long. So this is taking about 30 seconds in this case, and we now have a table which has 50 roads. And if I run leaflet here, we'd be able to see those randomly selected roads. So another challenge here is that maybe the full road is longer than this. So this one has the same name as the one that I provided. There may be roads that have either the same name or a similar name. Um, so this one is also the same thing. So this one has a longer name. So this is doing the job, but the challenge is the deployment part of it. Um, so this is the server part. Right now, it's not in the app. Now let's see the UI part. If I run the app, so I'm trying to make this a very attractive homepage that asks you about the road name here. Then you click on Explore, and then it should create a story that takes maybe I can limit it to, or we can limit it to 5 or 6 different roads, not 50. and then it can jump from one road to another and provide information about the landmarks in the area, or maybe more information. So I'm planning to use the story maps with the MapGL package. So here, if we look at, for example, this one, we see that it is in a certain area. It then highlights the property location, and then it shows that this location is within Austin. So we can do something similar. We can show one road, provide some information about that road, like the speed limit of that road. We can even use other packages like here our package to find the speed on that road, and then show that here, and then provide information about the landmarks that are close by, and then jump to or fly to another road. So this is in crux the three main things that is challenging for completing this app. So thank you for attending this, and this is the first meeting. In the second meeting, hopefully we have the deployment done, and we can discuss how that was done or other challenges that we have by then. So I welcome everyone to participate in this challenge. This is a Shiny Meetings challenge, which is posted on GitHub and other social media. Thank you.